Good day. I am Peter Rony, Professor Emeritus of Chemical Engineering at Virginia Tech in Blacksburg, Virginia. This YouTube video is about enrichment chemistry, and before I go further, I need to find enrichment. And here is a definition that I found on Google. It's a noun that means the act of making fuller or more meaningful or rewarding. So this definition is precisely the point of my use of the word. I have just studied the Amazon.com listings of General Chemistry textbooks. And here are examples of the front covers of the ones that I looked into. So, what are my conclusions about these textbooks? They all seem to lack what I call qualitative system identification. And what is that? I will discuss it later. These books are expensive, averaging $200 at Amazon.com for a hardcover new book. The renting of a textbook is new to me, and these textbooks are well illustrated and organized. At Amazon.com, I really appreciate the Look Inside feature, which allows me to view the table of contents and also the first chapter. Unfortunately, no student discounts are available. Well, I thought that this YouTube video would be initially directed toward teachers and students, but as I worked on it, I realized that really the focus of this video should be on textbook authors. And so I asked a couple of questions. I've been an author of a variety of textbooks on digital electronics and also microprocessor interfacing starting in 1974. So I ask, are you on a lucrative treadmill? There are a lot of general chemistry students that take such a course every year, so the national sales totals of such a book or such books should probably number at least in the hundreds of thousands. Are you subject to what I call the tyranny of revision every 2 or 3 years? And if you need to revise your general chemistry textbook, have you considered the possibility of adding engineering material to your revised textbooks? If your answers are generally yes, I suggest that you consider the content of my Enrichment Chemistry series, especially the complete book at a website called Teachers Pay Teachers. While thinking about textbooks, I have also thought about the plight of adults who have completely forgotten their general chemistry course. There should be tens of millions of such adults in the United States. And I believe a worthy objective for general chemistry textbook authors should be to increase science literacy for millions of adults. A light textbook would be available on Amazon.com, and it would be marketed by methods other than university reps and chemistry conferences. Most important, the light textbook should be substantially less expensive than a student textbook. It should be more qualitative and certainly focus on real-world systems. it can be less quantitative, and therefore no need for student manuals is the situation. And since they are not driven by chemistry course sales, there's no requirement to revise the LITE textbook every 2 or 3 years. And you need not worry about STEM guidelines, which applies to students and not necessarily to the general public. And I suggest that you incorporate in the LITE textbook what I call qualitative system identification. And you need not have hardcover books. You can rely on softcover and ebook versions. Well, why am I doing this? Well, I'm a chemical engineer, and I would like to impact general chemistry education worldwide. And why? Because I view the teaching of general chemistry differently than the view of a chemist. And I believe that my view is appropriate and valid today. My background, I am a chemical engineer by profession, and I've had 6 years of industrial experience and 31 years of academic experience. Since I'm Professor Emeritus, I don't need to pursue federal grants. The proposed mission is to really impact, as I said, general chemistry education. This is not restricted to the United States, but is an opportunity that exists worldwide. Now, I'm 76 years old. I'm probably too old to become a social networker. I am tweetless, textless, Facebookless, hashtagless, but I certainly use email frequently. I use a dumb phone instead of a smartphone, and my grandchildren consider me to be hopeless. I like this image. It has a bright yellow color, and it informs me and suggests to you that I am enjoying my 12 years of retirement. And one of the pleasures of my retirement is that I do not have to worry about a dean of engineering or department head of chemical engineering feeling that they have a better idea of what I should be doing with my professional career. For example, neither has thought highly of my book writing activity. And right now I'm certain that they would prefer, if I were still teaching, that I spend my time pursuing hundreds of thousands of dollars of research grants, when in fact my wife and I would be delighted for modest royalties so that we can visit our children and grandchildren more frequently. This is not my first effort to make available my ideas about enrichment chemistry. First, there is what I call the Enrichment Chemistry series at Amazon.com. I started with a complete ebook, which I will describe in a moment, but I've carved out 12 shorter ebooks. The 12 ebooks total 640 ebook pages. There is a total of more than 500 color images, and they all use the Kindle Mobi file format. If you want to find any of these ebooks, go to Amazon.com and search for the phrase Enrichment Chemistry Series. And when you go to the page, or 2 pages, you will see, I think, all of my 12 ebooks. Now, I plan to revise only books 2, 4, and 5 later this year. Here's where I started. The ebook is called Enrichment Chemistry Complete. It has a total of 640 ebook pages and more than 500 color images. And in comparison to Amazon.com, this single large ebook contains all of the ebooks in a single PDF file. How do you get this ebook? Well, you go to teacherspayteachers.com, you search for Peter Rony, and then on the resulting page you will find Enrichment Chemistry Complete, and you can download your initial copy for $10. What's really nice at TPT is that additional licenses for students can be obtained at a 50% discount. I don't expect that Enrichment Chemistry Complete is a substitute for introductory chemistry or general chemistry. It is not. It is an enrichment of the chemistry experience. Because it is so inexpensive, I ask you teachers whether it could be an effective supplement to a course textbook. Now, this year, 2015, I am creating a series of videos entitled the Enrichment Chemistry series on YouTube. This is July 2015, and I just started to create such videos. They are free, and each video will have a PowerPoint style that includes audio narration, and the uploads to YouTube are Windows Media Video File downloads, namely WMV, of the PowerPoint videos. And once you go to YouTube, search YouTube for the keyword phrase Peter Rony. As I've been looking at General Chemistry textbooks on Amazon.com, I came across this image which I really like. It's from the textbook, the title which is given, Fundamentals of General Organic and Biological Chemistry, 7th edition. And here the image states that chemistry is the central science. And in this case, the authors have focused only on health-related disciplines. Well, I see enrichment chemistry in a somewhat similar light. Not that I have written deliberately, but my complete ebook contains material that is associated with a variety of disciplines. Now, the most important material is related to chemical engineering, and especially human nutrition, some biology, and certainly environmental sciences. But the first book or two deals with astrophysics and astronomy. And why? Because I have been interested in how atoms in the periodic chart were created and why they have the different abundances that they do. So I feel that chemistry is a central science. In fact, I call it the queen of science. Well, let me get back to enrichment chemistry. I believe that it is a different and easier way to learn important principles of chemistry and chemical engineering. And here is really the most important message of my enrichment chemistry approach. You need not concern yourself with electron orbitals or hybrid orbitals. In fact, if you're a member of the public, do you even remember these two concepts? Well, my message is that molecules are the smallest units of meaning in chemistry. I got this quote from Philip Ball in one of his public-oriented books. Well, that's a pretty good statement. It's very appropriate because there are tens of millions of different molecules, and they come in a variety of categories, only a few of which are listed here. There are the small molecules: oxygen, nitrogen, carbon dioxide, hydrogen, methane, carbon monoxide, sulfur dioxide, and so forth. You already know and have heard of these small molecules, know what they are. However, a category that is very important are vitamins such as A, C, D, E, K, and the B group of vitamins. These are important in biochemistry and especially in human nutrition. You are well aware of biological polymers such as DNA and RNA, and on nutrition labels you are also aware of fatty acids and carbohydrates. For years you have been warned about hazardous molecules: DDT, PCB, poisons, explosives, and synthetic polymers such as polyethylene, nylon, polypropylene. I mentioned the phrase qualitative system identification. So what is this phrase? Well, it pertains to the question, what do you need to know about a selected molecule? And here are the questions. What is the molecule? Where is the molecule located? What amount of the molecule is present in each of its location? And what is the molecule doing in each of its location? So this is sort of qualitative, except for amount. The first, second, and fourth questions are qualitative, which makes them easy to answer. Well, here we have 4 qualitative questions. Is there any general principle that can be applied to each of these tens of millions of molecules? My answer is yes. The general principle involves the concepts of identity, location, amount, and rate processes. And these are the concepts that are the basis of my approach, which is called enrichment chemistry. So the first question I ask about a complex system are the 4 shown here. What is the molecular identity of a molecule that is of interest? What is the molecular location, actually locations, of this molecule? What is the molecular amount in each of these locations? In many cases, this amount is difficult to measure or estimate, but it should be acknowledged that you need to know how much of a molecule is located in different places. Finally, there is molecular rate process. And for general chemistry textbooks, they focus on reactions, but they do not focus on the processes of diffusion and convection. Well, of these 4 concepts, I'd like to focus the rest of this YouTube presentation on location. The message I want to give you is a molecule can be in several different locations simultaneously. Well, you already know this because you know that a molecule could be dissolved in a liquid phase, such as water, and simultaneously be present in the gas phase, such as air. But a molecule can also be dissolved in a polymeric solid, organic polymer. It can also be present at the interface between the gas and liquid phases. It could be adsorbed on a surface. Note the letter D, adsorbed. And it could be bound to a biological molecule in a biological cell. So let me give you some examples of location. Here we have a household water purifier. I guess water ends at the tap water ends at the top and comes out the bottom as purified water. Now, the key component of this purifier is what is called activated carbon. There's a whole bunch of activated carbon. And activated carbon is a remarkable solid. It has a very large internal surface area, and it's designed to attract and adsorb with a D, organic pollutants like phenol, chlorinated hydrocarbons, and get them out of your tap water. So activated carbon is a location, and the specific location is your molecule of interest that is on the internal surface of the carbon. Well, at the upper right is a different type of system familiar to you. It's oil and vinegar salad dressing. And here we have a little decanter where we pour in a bottom layer, which is vinegar, and a lot more of a top layer, which usually is or should be olive oil. And then these black particles are herbs and spices. And I think in the bottom layer you may see some little pieces of onion. So to prepare Italian dressing, which is what this is called, you put all these ingredients in and close the top and shake vigorously, probably for 10 or 15 seconds. Once you finish shaking, you put the decanter on a surface and you let it sit for several hours, after which you can shake the mixture again. And the idea is to get the organics in the herbs and spices solids to be infused into both the oil and the vinegar aqueous solution. So if you have a molecule, let me call it acetic acid, it would be found in several locations. First, most of it in the aqueous phase, this low pink-colored liquid, and then some of it in the olive oil phase, and some in the air above the olive oil. So you open the decanter and smell it, you'll have a vinegar smell. So you have several locations in this simple system. Let me now move to the lower left image. This image depicts a surfactant, which I believe is a very interesting type of molecule. It's a long molecule. On one side it has an inorganic end. The inorganic end could be a carboxylate, a sulfate or something, but something ionic that is attracted to water. Then for the rest of the molecule, it's a hydrocarbon. It has a very long hydrocarbon chain, and such chains are not soluble in water at all. And as you can see, the surfactant molecules align themselves in the following way. The heads, the ionic heads, are dissolved in the water phase, and the nonpolar organic rest of the molecule is oriented above the water phase. Now, the phase above the water can be air, or it could be organic liquids such as olive oil. And what you have done is have a surfactant film on top of the water. And why would you do that? Well, such a film represses the evaporation of water into the air. So the film just serves as a barrier, and water molecules have a problem penetrating this very, very thin surfactant barrier. Now, surfactant molecules are also useful to create foams and emulsions between water and oil, and they are used in cosmetics. Now, in the lower right, we have a biological system. We have a simple example of a receptor. Now, if we consider or select a drug molecule, which is this little red thing, as our molecule of interest, then this location where the drug molecule is attached to the receptor is considered a location. And there are hundreds of thousands of these type of receptor locations in a single biological cell. Finally, I thank you for listening to this YouTube presentation, which is my first in my enrichment series, Enrichment Chemistry series on YouTube. Good day.